Well, welcome back. In this module, we're going to focus on how city design can play a role in optimizing the use of energy. Now, we don't usually think of cities as being the critical variable when we're talking about energy, but in ways that are large and small, they have an important impact. Anyone involved in designing cities, I think, has to be aware of how they can make a difference. Now, we've titled this session Managing Energy Consumption because there's no such thing as a zero energy city, despite what people say. Energy is what makes cities possible. The kind of energy we use, how we use it, and the things that energy drives in a city are the things that we have some control over. So why is this subject important? I think there are three big reasons. First, the production and the distribution of energy is costly, and it's going to cost even more in the future as fossil fuel becomes much more scarce. Second, replacing current energy systems with various kinds of alternative forms of generation, wind power, water power, and so on, requires us to put whole new networks into cities. And third, energy is the single most important component of global warming. And for that reason alone, it would be worth worrying about how much energy we consume and how we consume it. So let's start with some statistics.
In the U.S., buildings and the activities housed in them consume roughly 40% of all the energy used. Transportation, which includes cars and public transit and trains and trucks and aircraft, consumes about 30% of the energy in the industrial sector, roughly the same amount. The vast bulk of buildings are in urban areas, and a large fraction of the energy consumed there for transportation is as well. So let's start with thinking about how to manage urban energy consumption. It's worth noting that in other parts of the world, far less energy is consumed by transportation and far more by industrial uses, particularly in China. And large oil-producing countries consume the most energy since it is very cheap, while the older cities in Europe, where energy is very expensive, consume the least amount per capita, if one takes account of the level of GDP. The things we can do better to manage energy consumption fall into two categories. We can reduce demand by creating urban forms that are more energy efficient, by reducing travel, shifting to more efficient types of travel, making our buildings more efficient, and locally sourcing things. And we can improve the supply of energy by shifting to renewable sources, installing district heating and cooling, and reusing waste heat, and by developing new systems to control and optimize energy. Let's take a look at a few examples in each of these categories. Urban form affects the consumption of energy in many ways. The most important is how spread out our cities are. As this chart shows, in European cities where people consume much land per capita than in North America or Australia, the gasoline consumed is far less. And within the U.S., newer, more sprawling cities consume more fuel than older cities like New York and Philadelphia. Interestingly, Los Angeles is a relatively dense city, and it ranks closely with New York in terms of the amount of gasoline consumed. Studies have shown that there's a very close inverse relationship between the density of a city and the amount of gasoline consumed. The higher density, the lower the consumption. In a city like Tokyo, most daily needs are within easy walk, and transit lines are never more than a few blocks away. While in Los Angeles, there are a few large clusters of activity, but you generally have to drive to get there. Transit is now being built that would change that, but only a minority of residents will live within easy range of a transit station. Now, this image of Toronto shows how, over time, the density of city can be reconfigured by the available transit. The North Yonge Street corridor now resembles a string of pearls surrounding each transit station. Where there are east-west streetcar lines, development spreads outward from the subway station. Over the past 10 years, Toronto has taken another bold action of creating a green belt around the city that stops the spread of development and makes high-quality transit possible to all within the green belt. Vancouver, also in Canada, created a similar green belt in the form of an agricultural reserve around the city about 35 years ago. This image shows clearly the effects of the urban limit line, and densities within the urban area have climbed steadily, especially in areas that are well served by transit. This shows the pattern of densities in 1991, and this shows the pattern of high-density areas in 2006. New Westminster, which is about 15 kilometers from downtown Vancouver, has developed a lively, high-density urban core thanks to the easy accessibility to other parts of the region by the SkyTrain. And of course, mass transit isn't the only way to reduce dependence on automobiles. Encouraging people to walk or cycle are other ways. Mixing housing and shops and schools and entertainment so that you can reduce the need for travel is another. Allowing people to work and live in the same area is still another. And this image shows the idea of creating complete streets that do all that and are designed equally for pedestrians, cyclists, bus riders, as well as motorists. In European cities, they make sure that transit lines are constructed before development so that people moving there don't get in the habit of driving. This example is from Stockholm, Sweden, in a new development that's called Hammarby. We are also our own worst enemy when it comes to using energy. Because of the many hard surfaces in the city, the temperatures of dense urban areas are generally 5 to 7 degrees Fahrenheit higher than in the surrounding rural areas. This makes it uncomfortable to walk outdoors, and it greatly adds to the air conditioning bills of everybody who lives in the area. One thing that we can do is to increase the shade in cities by planting trees. This image of Cour-Mirabeau and Aix-en-Provence in France shows just how wonderful it can be. We can plant rooftops that not only cool the building below, but also absorb water and provide new green spaces for a city. Even the simple act of changing the color and the reflectivity of a parking lot can lower its temperatures under the hot sun. But sunlight also has its advantages, especially in colder climates. Passive solar energy can help heat housing and capture the breezes above the rooftop to help eliminate the need for mechanical fans to circulate the air within the building. Some cities like Chicago have taken the lead in surveying all of its buildings in the central area to determine which ones are the most and which are least efficient. They then know how to direct public subsidies for upgrading building envelopes and systems to perform better. With new buildings, there's a chance to incorporate systems that use the sun and the wind and natural processes to lower the overall energy needs. The new Bank of America building in New York aims at reducing to a minimum the outside energy needed for heating, lighting, and air conditioning. To do so, it incorporates the most sophisticated systems of generating energy internally, capturing energy from daytime use during the night, and in other ways conserving energy. But you need not build skyscrapers to conserve energy. Locally sourcing food saves thousands of miles of trucking while providing healthy foods on the table of local residents. Managing energy also requires the right mix of energy sources. In European and many Asian cities, there's been a great deal of investment in waste-to-energy facilities where garbage that cannot be recycled or composted is burned to create new energy, either for heating or electric power. Other cities have converted energy plants to burn wood pellets produced in dedicated stands of fast-growing woods. There are also opportunities for generating energy from wind in urban areas. This installation at Logan Airport in Boston takes advantage of the large windswept areas that characterize most airports. And the tops of many acres of parking garages at the airport have also been layered with solar panels. Ultimately, every structure in the city has the potential to generate as well as consume energy. In Freiburg, Germany, there are now over 5,000 installations of solar collectors, and the city has created a solar electric utility. In northern climates, the largest energy challenge is to reduce the heating costs of housing. By acting collectively and creating small district heating utilities, it is possible to accomplish this. This small project outside of Calgary, Alberta in Canada eliminates over 90% of the outside energy needed for heating by installing solar panels over backyard garages and by using thermal energy from the earth. This is the layout of the system, and it is in a location where natural gas and oil are abundant. The new neighborhood of Hammarby in Stockholm, which I mentioned previously, thinks even more expansively by conceiving of the city as a series of closed loops. Each of the systems that involve water, energy, and waste have been examined and coordinated. Thus, garbage becomes the fuel for generating electricity, and the waste heat from this process is used for heating buildings. Water is recycled to reduce the energy needed for treatment, and so on. At the Olympic Village in Vancouver, a district energy facility was created to serve the wider neighborhood where it's located. And among its many innovations is that it harvests heat from the sewer lines and reuses it for heating buildings rather than literally flushing the energy down the drain. I could go on forever discussing innovations in managing energy consumption, but it has also become clear that to make the most of the systems of a city, there's a need for sophisticated management and control systems with sensors that track real-time demands and usage of energy. Many large firms like Siemens and IBM are working on cities to install these systems. They allow cities to think comprehensively about energy across all their systems.
Despite what the manufacturers of products tell you, there's no single magic solution for managing energy consumption. All at once is what's necessary. And because energy use is so ubiquitous, it needs to be on the minds of every city designer every time they work on a project, every time a policy is considered. We also need to know a lot more about how the form of cities affects energy consumption. We need to know how density affects the choices people make for traveling, and what the actual savings are when we substitute one form of energy for another. We're just beginning to understand what we can change and what we can't change in cities. So the next session will carry this topic a little bit further, and we will begin to look at the question of electronic networks in cities.